Hi, I'm Brian Patty with VAplus. I, along with my colleagues John and Adam, participated in Autodesk 4-part webinar series designed for safety following COVID-19. Session 3, Analysis Focus. In this video, we will cover how it is that we became involved with a local school in trying to help them reopen, what kind of data they typically have available for us to use, what tools we use to evaluate classroom capacity and COVID-19 safe routing, and how we analyzed our design results with Autodesk Infraworks Mobility Simulations.
VAplus got involved with UPrep out of need based upon the fact that I'm a parent of a scholar at this elementary school, and quickly recognized that if we did eventually go to in-person with the new COVID, social distancing and all the other things that were in the news as being able to be handled, that it was going to make dismissals very difficult, and it seemed like it was going to be a little bit of a logistic nightmare. And so I reached out while getting supplies to do virtual, online learning for my son. Reached out to Alistair, the chief operating officer at UPrep, and requested a meeting with him to kind of go through some of the stuff that we thought we'd be able to do. And we had just been introduced to Infraworks and Mobility Simulator, and it felt like it would be a great way to take some of our other COVID social distancing tools and stuff that we had developed and be able to prove and demonstrate that the solutions were workable and fine-tune stuff without experimenting on students. Quickly ran into, there were some interesting challenges to overcome. A few of them being that there was a bunch of different transportation modes to take on. They have buses that had a very limited window. They had pedestrian pickups, and they also had car pickups. And at the Steel Street campus, they had an additional one beyond the Arapahoe campus. They have students that are released and they just walk home. So we've got a bunch of different modes to take care of. They also have limited staff to watch the kids in class, as well as watch for parents coming up to be able to pick up their kids. So they have to walkie-talkie, communicate back and forth. So they couldn't have too many points of entry or dismissal because they wouldn't have enough staff to cover that. Also, just being able to maintain cohort separations. In Colorado, they're doing basically cohorts where in the elementary schools, they're essentially not mixing these small groups of students to be able to contain outbreaks and things like that. So those were all things that we started to deal with and started to use the mobility simulations to prove what we had essentially done, taken PDFs and CAD files because each campus had a different piece of that. And we put them into Revit, used our COVID planning tool to do some spacing. In one case, we did a manual operation where we were able to pull in and lay out some classrooms. And we've also taken advantage of the generative design tools to try to give them some more options, understanding, again, where is the display or chalkboard wall versus student circulation and the teacher circulation amongst all that as well. And we've gone back and forth a couple different times with this now, and the response has been pretty amazing as far as them being able to see how things are working. I think gives them quite a bit more confidence that they can focus on the little details to actually make sure that this is implemented safely and see problems that they probably wouldn't be able to see if I just showed them sketches or plans of the routing and things like that. I mean, obviously being able to show, hey, here's how you need to lay out your classroom is quite helpful. And also, this is how you need to operate your one-way routing to keep cohorts from mixing.
Our workflow utilizes the generative design tool in Revit to create new classroom layouts. For this classroom, we will be generating a layout of student desks using a modification of the workspace layout script that comes with Revit's generative design tool. This allows us to explore configurations and find the upper limit of how many student desks can exist in the room while complying with social distancing guidelines. We have modified the generative design script to also place our workspace family in addition to station furniture. These workspace families are a representation of an occupancy point, which is common across our workflow and allows for both generative and manual placement to have identically accessible, machine-readable results that are managed and reportable through our Workspace Density Planning tool add-in, which also makes this data available for tools outside of Revit in the form of plain text files. In this project's case, the guidelines specify a radius of 3 feet for students and 6 feet for instructors. The social radius and inner human radius of workspace families can be adjusted in the family type, and multiple types can be used to represent different kinds of occupant stations, or to represent circulation nodes. Next, we generate layouts in the Revit Generative Design tool. Then select a desirable layout, and Generative Design places our workspace families in the model. A 6-foot radius workspace type is also manually placed to represent the occupancy point for the instructor. But, in order to represent the higher mobility of this role, which must have access to the student workspaces, we will also place circulation nodes, which can be created as a type in the same workspace family by enabling the circulation parameter. This can signal to other tools, such as the Workspace Density Planning tool, other add-ins, or Dynamo scripts, that the instances of this type are to be evaluated as a passage with revolving occupancy which does not count towards occupancy totals of a room. Circulation nodes are placed in the aisles created by the Generative Design scripts layout, and we run the Workspace Density Planning tool to create a report. This process is performed for all the classrooms at the school. The passing workspace family instances will inform the final occupant counts for each classroom that are used downstream in Infraworks Mobility Simulation in order to create a mobility study.
Mobility Simulator in Autodesk's Infraworks was the perfect tool for us to use to validate our proposal. We were able to simulate our specific dismissal proposal and see if it met our client's goals and COVID-19 guidelines. The tool has enabled our clients to really visualize the dismissal plan and promote a more informed conversation leading to the best solution path. Benefits of using Mobility Simulator include showing how long dismissal and arrival will take, showing the length of each student trip, showing if social distancing is being met, and representing traffic density at the pickup zone. Using the dismissal plan PDF outline, a network is created in Mobility Simulator to simulate the dismissal sequence. Classrooms are represented by areas as well as the bus stop and pedestrian pickup zones. This allows us to route students from all classrooms to the bus stop, the pedestrian pickup zones, as well as to the vehicle pickup zone based on real data provided by the school district. Social distancing is simulated by increasing the space parameter for people to the desired social distancing radius, as well as by adjusting the capacity of walkways to equal the length of the walkway divided by the social distance radius. We wanted to show the bus dismissal taking place before the rest of the students' dismissal to reduce the corridor load, so we set up some additional terms and demand profiles allowing us to stagger the dismissal of groups of students. Many school layouts will lead to conditions where there are multiple routes which connect destinations. This can be helpful in simulating typical situations where people will randomly make choices, but for our purposes, we want all of the students to follow their dedicated paths, helping avoid collisions. We utilize the route spreading tool to eliminate deviation from the main paths. This tool is also used to test the network and make sure routes are connected and functioning as planned. We wanted to use the simulation to show the potential impact our plan would have on the vehicle queue for pickup, so we incorporated the vehicle pickup into our simulation. We have a group of cars assigned to fill up the pickup lot over the simulation time. As students arrive in the pickup lot, they will get into a waiting car and leave. We increase the time for the students to get in the car to help simulate additional time that the cars will be waiting in the parking stalls. To evaluate the simulation, we utilized the information shown in the Analysis tab, which gives a summary of trips with times and distances. We then reviewed the walking reports, which show individual trip times and distances, and the level of service, which shows if the spacing is being met on all walkways. These tools can show that the client's goals are being met and their concerns addressed regarding the time for dismissal and the ability to enforce social distancing. Mobility Simulator can be used to solve a range of problems related to getting students safely back to school, from arrival sequences and class transition sequences to simulations for middle and high schools, as well as parking and class transition simulations at universities.
We are VAplus, an innovative BIM consulting firm located in Denver, Colorado, with over 15 years of experience working on projects around the world to bring designers and clients' visions to fruition. Contact us today about our services, such as BIM modeling, BIM management, as-builts and conversions, scanning and point cloud services, custom solutions, and beyond. Learn more at vaplus.us. And thank you for watching.